United States, a corner-grounded delta 240-volt system is legal according to the National Electrical Code. Yes, a circuit breaker protecting the grounded corner phase would trip to ground in the event of a ground fault. The concern about the grounded phase potentially shorting and energizing the equipment frame is valid. However, if the system is properly installed and grounded, this scenario should not occur. The National Electrical Code requires that the grounded conductor, often called the neutral, be bonded to the equipment grounding conductor, often called the green wire, at the service entrance and at each subpanel. All exposed metal parts of the equipment must be grounded. With these measures in place, any fault current will flow through the neutral and grounding conductors, preventing it from reaching the equipment frame. In addition to following the National Electrical Code requirements, consider the following precautions. Firstly, use equipment that is specifically designed for use on a corner-grounded delta system. Secondly, ensure that all connections are tight and secure. Thirdly, periodically inspect the system for any loose connections or damage. Fourthly, provide proper signage to indicate that the system is corner-grounded delta. While a corner-grounded delta 240-volt system is legal, it is important to install and maintain it properly to ensure safety. By following the National Electrical Code requirements and implementing additional precautions, you can minimize the risk of electric shock and protect both the equipment and the operator. A corner-grounded delta system is a type of three-phase electrical distribution system where one of the three phases is grounded. This differs from other common systems like Y systems where the neutral point is grounded, or a delta system with a center tap on one phase grounded. Let's consider some key aspects of corner-grounded delta systems. Firstly, legality. As mentioned earlier, the National Electrical Code in the United States permits corner-grounded delta systems. However, local codes and regulations may impose additional requirements or restrictions. It is important to consult with local authorities and electrical inspectors to ensure compliance with all applicable regulations. Secondly, grounding. The grounding of one corner of the delta provides a reference point for voltage measurements and helps to stabilize the system voltage. It also provides a path for fault currents to flow back to the source, allowing overcurrent protection devices like circuit breakers and fuses to operate and clear the fault. Thirdly, overcurrent protection. Circuit breakers and fuses are essential components of any electrical system, including corner-grounded delta systems. They are designed to protect the system from overloads and short circuits. In a corner-grounded delta system, a ground fault, which is an unintentional connection between a phase conductor and ground, will cause a large current to flow through the grounded phase. This current will trip the circuit breaker or blow the fuse, interrupting the power supply and preventing damage to the equipment or injury to personnel. Fourthly, safety. Safety is a paramount concern in any electrical installation. A properly installed and maintained corner-grounded delta system can be safe. However, it is crucial to adhere to all applicable codes and standards and to take necessary precautions to prevent electrical hazards. Grounding is a critical safety measure. As mentioned earlier, the grounded conductor must be bonded to the equipment grounding conductor at the service entrance and at each subpanel. This provides a low impedance path for fault currents, ensuring that overcurrent protection devices operate quickly and effectively. All exposed metal parts of the equipment must also be grounded. This prevents them from becoming energized in the event of a fault, which could pose a shock hazard. Fifthly, equipment selection. It is important to select equipment that is specifically designed for use on a corner-grounded delta system. Some equipment may not be compatible with this type of system, and using the wrong equipment can lead to problems. For example, some transformers are not designed to be used in corner-grounded delta systems and can be damaged if they are. Sixthly, maintenance. Regular maintenance is essential to ensure the continued safe and reliable operation of a corner-grounded delta system. This includes inspecting connections for tightness and corrosion, testing grounding conductors for continuity, and verifying the proper operation of overcurrent protection devices. Any loose connections or damage should be repaired promptly. Seventh, signage. Proper signage is important to alert personnel to the fact that the system is corner-grounded delta. This can help to prevent accidental contact with energized parts and to ensure that proper procedures are followed when working on the system. The signage should be clear and conspicuous and should be placed in areas where it is likely to be seen by personnel. 8. Potential issues. One potential issue with corner-grounded delta systems is that they can be more susceptible to voltage imbalances than other types of systems. This is because the grounded phase is not equally loaded with the other two phases. Voltage imbalances can lead to overheating of motors and other equipment. 9th, additional precautions. In addition to the precautions mentioned earlier, there are other steps that can be taken to enhance the safety of a corner-grounded delta system. These include using ground fault circuit interrupters, installing surge suppressors, and providing training to personnel on the proper procedures for working on the system. Ground fault circuit interrupters are designed to detect ground faults and to interrupt the power supply quickly. This can help to prevent electric shock. Surge suppressors protect equipment from voltage surges which can be caused by lightning or other events. Training is essential to ensure that personnel are aware of the hazards associated with corner-grounded delta systems and that they know how to work on them safely. Remember that specific requirements will vary based on local electrical codes and the application itself, so consulting with a qualified electrician or engineer is crucial for ensuring a safe and compliant installation. Also, it is worth noting that although it is a less common system than a Y-connected system, there are specific cases where a corner-grounded delta system may be preferred. Some of these reasons are firstly, improved system protection. In certain industrial applications where a high degree of system protection is required, corner-grounded delta systems can provide enhanced ground fault protection. The grounded corner provides a direct path for ground fault currents, enabling faster detection and clearing of faults. Secondly, reduced neutral currents. Compared to Y systems with a neutral conductor, corner-grounded delta systems do not have neutral currents under normal balanced load conditions. This can be advantageous in applications where neutral currents can cause issues such as interference with sensitive electronic equipment. Thirdly, simpler design for specific loads. For some specific load types, such as resistance heating loads, a corner-grounded delta system can offer a simpler and more cost-effective design compared to other system configurations. When installing a heating press, consideration must be given to the press's voltage requirements and the voltage output of the electrical system. If the press is designed for single-phase 240 volts, it must be ensured that the supply can consistently provide this voltage under load. Voltage drops can affect the performance and lifespan of the heating elements. All components, including circuit breakers, conductors, and connections, must be rated to handle the press's current requirements. Overloading these components can lead to overheating, damage, and potential fire hazards. Grounding the frame of the heating press is essential to protect the operator from electric shock. The grounding conductor should be properly sized and connected to the equipment grounding system. Proper signage must be used to indicate that the system is a corner-grounded delta. This is especially important in areas where other types of electrical systems are present. The signage should clearly identify the type of system and any specific safety precautions that need to be taken. The equipment should be inspected and maintained on a regular basis to ensure that it is in safe operating condition. This includes checking for loose connections, damaged insulation, and other potential hazards. The specific maintenance schedule will depend on the equipment and the operating environment. In summary, while corner-grounded delta systems are legal, they require careful attention to detail during installation and maintenance to ensure safety and compliance with electrical codes. Grounding, bonding, overcurrent protection, and adherence to the National Electrical Code are key factors in preventing electrical hazards and protecting personnel and equipment. If there are any doubts, consult with a qualified electrician.